Okay, 19 is a polynomial inequality. So you find the critical value. The critical value is the 0, and you convert this inequality to equation. And you solve the equation using the zero factor rule. The solution is 5 and -2. And this is the critical value. Okay, using the critical value, we are doing the partition of the all real number line. So we have a -2 here and 5. And you select the testing point before and after each critical value. Suppose -3, suppose 0 here, and suppose 6. Okay, after we are doing the chart in which you put here the testing point. The testing point are -3, 0, and 6. And in the column you put each factor, because x minus 5 square, x plus 2, and the total sign. And you evaluate this point in each factor. Es obvio que in this column always is positive. Why? Because it's a square. And a square, any positive or negative number is always positive. But in this case, no. In this case, -3 here, you evaluate -3 plus 2, and -1. This is negative. I don't care the value, I care the sign. 0 is positive, and 6 is positive. So now, the multiplication this and this is negative. The multiplication this and this is positive, and the multiplication this and this is positive. Okay, so what is the true part? The true part, remember, our inequality is less than. Less than is negative, so this is the true part. This is positive, it's completely false. False and false. Then you select the interval when it's true, because this interval. This interval is true, because when you have -3 here, that's true. Okay, and of course do not include the endpoint -2, because this inequality have no equal. No, this is no equal. No equal. Okay, then solution for our problem is the interval from -infinity, -2. Or is x such that x is less than -2. Okay, they are equivalent. Okay, 21. You convert this to equation. You solve this equation. This is a factorial equation. It's obvious that the solution is 0 and 4. And this is the critical value. Now let's use the critical value for doing the partition. Zero and 4. 1, 2, 3, and 4. Okay, after we select the testing point may be -1, maybe whatever here, 2 and 5. And after we're doing the chart. testing point, and the factor. Testing point is -1, 2, and 5. And the factor associated in our problem is x squared and x minus 4. And total signs. I completed the chart. And let's analyze the signs. Okay, the sign is positive here, always, because it's a square. Doesn't matter the sign of the number. And this, let's see what happened. This is minus, because -1, -1 and -4, -5 is negative. 2 here, 2 minus 4 is negative again. Now 5 is positive. So this multiplication, this is minus, and this is plus. So let's analyze. The only part is true is this part. This is true, this is false, and this is false according to my problem, with the problem is greater than positive. Okay, so you highlight this part que corresponde with this interval. And of course do not include 4, because our equation, our inequality have no equal sign here. Now the solution is parenthesis 4, infinity, or x such that x is greater than 4. It's the same thing. Okay, polynomial inequality. The first thing you should do is express in a standard form, moving this to the left, plus x to the second power greater than 0. And find the GCF. The great common factor is 2x squared. Is x plus 2 plus 4 greater than 0. Now convert this to equation, because I want to find the critical value. It's obvious that the solution is 0 and -4. This is the critical value. Using the critical value, let's do interpretation. A real number, 0 and -4. This is 0 and -4. I suppose -4 here. And you select a testing point. Testing point is maybe getting -5 arbitrary, completely arbitrary in each interval. Whatever, -2 and +1. Okay, after that you're doing the chart using the testing point. The testing point are -5, -2, and +1. And the factor in our expression, this is our expression, are 2 no. 2 always is positive. X squared and x plus 4. And 1 extra column for the total sign. And this is our chart. Okay, and you evaluate -5 in each expression. Well, this is a square, that's always is positive. Okay, so this is -5 here, -5 plus 4 is -1, that's negative. And positive times negative is negative. -2 here is positive, because -2 plus 4 is positive too. Positive and positive is positive. And 1 is positive. And positive and positive is positive. the only interval is true is this and this. This is false. Why? Because our inequality is greater than. Greater than means positive. So the one is positive is true. Okay, then the interval is true is the interval. This interval incluye negative 2 and this interval can include positive 1. And this is infinity. Continue forever. However, 0 is not included in the solution and negative 4 is not included in the solution because our inequality is a strict inequality, have no equal sign here. This is negative 4, negative 4, comma 0, union 0, comma infinity. It's the interval solution, right? And the other way is x that x is in between negative 4 and 0, or x is greater than 0. This is the solution for the 43.